Welcome to GetXAML. In this video, we'll see a very simple explanation of nav-based classifier. Okay, I will tell you a simple method, a three-step method to find or understand this classifier. There are a lot of mathematical terms. We will not worry about it or memorize it. We follow these three steps, and then we'll take this example. With this example, we'll try to understand and then derive the formulas also. Okay, so formulas are not meant for remembering. Okay, you understand the concept, you need not apply the formula also. When it comes to exams, you need not memorize and apply the formula. If you know how to solve, or that is, you have understood the concept, definitely you can do it. Okay, so before understanding the classifier, naive-based classifier, so the background we need is some of the concepts I have explained already in the probability and statistics video lectures. So we need to understand conditional probability, using that you have learned the Bayes theorem, and then concept of conditional independence. I have pinned those video lectures in the comment box. Please go through it. You just understand what they mean. Okay, that is sufficient for understanding this naive-based classifier. Okay, so let's begin. Let us take this example. This is basically a classifier. So I want to classify a given input to particular class. So let us take an example of email. So in the email, we create two classes. Say the mail is spam or it is not a spam. Spam means unwanted mail. Not a spam means it's a correct mail which has to be sent into your inbox. Now for this, we are given the data. Let us assume this data. 5 emails data is given. What it contains? It contains two variables or two features, x1, x2. Let us say x1, x2, and then it gives the label, that is which class. Okay, spam or not spam. There are only two classes we assume in this example, and two features, x1, x2. What is x1? X1 is nothing but if the mail contains the word like free. Okay, x2 says if this feature contains the word like win. What is the data here? Yes means this email E1 contains the yes means contains free keyword in this email. Similarly, yes in win means contains the keyword win in that mail. So the label given is spam for it. So like that, you are given the data set of 5 emails. Now the task is you have to classify a new email. Say x new is a new email I'm getting. Contains both free and win. So the email that we got, okay, that you have to test, contains both these keywords. So this will play an important role. Later we'll understand. Okay, now let us start understanding the concept, how this naive-based classifier classifies this. So let us do it in 3 steps, very simple steps. So step 1. So given the data set, given this data set, from the data set, you calculate the probability of each class. Let us represent class as C, the variable, random variable C. X1 indicates free, X2 indicates win. The data is given. So let us calculate the probability of each class. Each class means what? There are only two classes, spam or not spam, from the data set. So the first step, from data set, calculate probability of each class, probability of class spam. How will you find? So out of five samples I have here, how many are spam? 3 are spam. 1, 2, 3. So 3 divided by 5. Then the other class, probability of not being spam. How many are not spam? 1, 2. So out of 5, 2 are not spam. So this is the first step. First step, from the data set, find the probability of each class. This probability, we call it as prior probability. Priori or prior. Okay. What this means? The prior means what? Before I predict something, what are the probabilities of the classes? So already from the data set we are calculating, so it's the prior probability. That means this is the knowledge I have. This is the entire knowledge I have. Based on that, I am checking what are the things there. Next. Step 2 is very important. Now, from the same data set, you calculate these variables features containing yes or no. What exactly it means? 3 equal to yes. That means x1 equal to yes, or it can be x1 equal to no. So there are only two possible combinations. It is, I'll write it here. X1 is equal to yes. That means what? X1 means free. Free is equal to yes, or free is equal to no. Now, what is that you have to calculate now? Whether yes or no, or yes or for no. How will you come to know? That's what I told you here. So what the email contains, it's saying it's free and win. So that means what? I have to check how many of these variables or feature contain free is equal to yes, right? Because finding no will not help me, because it's the email what is contains free. So free is present. If there was no free word, then I have to check free is not there. For those probabilities you have to calculate. So how will you calculate? Let us say probability of x1, that is x1 means yes, x1 means free. Free is equal to yes, is present or not, because I want to check this. This is yes, this is also yes. So x1 equal to yes, given it is a spam. What is that I'm trying to find out from the data? I'm trying to find out all those features which contain yes and they are classified as spam. That gives me some information, right? If this word is present, then what is the probability that it is labeled as spam? So that is nothing but your conditional probability. That is probability of x1 equal to yes, that is free is equal to yes, given that it is a spam. When I know that it is already a spam, then what is the probability that it is free? Free keyword is present. When a mail contains a spam, as classified as spam already from the data set, then what was the probability that it contained the word free? That is the meaning. So how will you find this probability? X1 equal to yes, given spam. How many are given spam here? 1, 2, 3. These three values are spam. And then check the corresponding this x1 value. For spam it is yes, yes, yes. That means what? Out of 3, all 3 are yes. So 3 spams are there and all 3 are yes. So this is 1. Similarly, probability of x2 is equal to yes. Why yes? Because it also contains the keyword win. That's what they are saying. If they are saying only free, there is no win, then I have taken x2 equal to no. Then calculate for given spam how many are no. That's how I have to calculate. So that gives the conditional probability. I will to find given it is spam. Again, given it is spam, how many of them contains the keyword win? So 1 and then 2. So this is 2 by 3. Okay, next. Probability of not spam. So I calculated spam for class spam, and now I have to calculate for class not spam. So that is probability of x1 is equal to yes, given that it is not spam. So I will calculate this. So not spam, how many are there? 2 are there. In that, yes is 0, because both are no here. So this is 0. Probability of this is 0. Probability of x2 is equal to yes, given that it is not spam. So not spam, again, only 2 emails contain not spam, are classified as not spam in this data. And then one of them contains win is yes. Okay, x2 is equal to yes. So that means 1 out of 2. Whatever you calculated is called as the likelihood. Likelihood means what? The given this new data or test data, you are calculating the likelihood based on the given data. What is the likelihood that it may belong to this or this or this or this? Okay, so first step, find the prior probability. Second step, find the likelihood. So likelihood you calculate it as conditional probability based on what is the variable of interest here. This is important. So once you found out this, next is the step 3. Step 3 is final prediction part or final classification part. Now, what is that I have to find out? I have to find out probability of class, because I have to find out the class, which class. Okay. whether it's spam or not spam, given my new data. For this new data, what is the probability? Okay, what is the probability of spam for this new email, or probability of not spam for this new email? So I can use Bayes theorem and conditional probability to write it like probability of T given x new can be written as, you already calculated from the data the likelihood, that is x given class into probability of this class divided by probability of x. Okay. This is nothing but your Bayes theorem. Now, how will you find out? You already found out these values. What naive Bayes says is, if you observe this p of x, okay, p of x means it can be x1 or x2. So for every class, whether it's spam or not spam, this value will remain same. Okay, see, there are 3 yes and 2 no's. Okay, for x2 also there are 3 yes and 2 no's here in this. So p of x, whenever I take for spam or not spam, it doesn't matter, right? This p of x value remains same. So this says probability of class given the new x value is proportional to probability of x given c into probability of the class divided by nothing. So you are just removing it. So this is the basic rule of naive Bayes. Now here this is still not over, because this x is it contains multiple variables, that is it contains both x1 and x2 here. It may contain any number. So in that, how will you find? So this is nothing but p of, so I am deriving the exact formula for naive Bayes. So c of given x new is equal to, this nothing but this is proportional to probability of, I have two variables here, x1, x2, given c into pc. So what is this probability? To observe here, this is nothing but your likelihood. That's what you have calculated previously here. This is what you have calculated, x1, x2 for each class, into what is this? This is your prior probability. This is what you have calculated for each class. For each class, you have calculated that. That will give me the estimate or the classification, that we call it as posterior. These are the terms they use. This is called posterior probability. So this is nothing but step 3 is finding the posterior probability. That means what this is, you are taking the likelihood and multiplying with the prior probability, that we call it as, this step we call it as updation. So you take likelihood and then update it, you will get your posterior probability. This is the core fundamental of your naive Bayes theorem. For the multiple variables, how will you write it? So probability of c x, it is given this value, what is the class? This is nothing but, say, let us say there are n variables. If there are n features or n variables, we'll write it as like this, given c into probability of each class. Now, this is nothing but what? The naive Bayes assumes conditional independence among the features. What it trying to say is, see, this feature is independent of this feature, but in real world they may be dependent, but even if they are dependent, this algorithm, naive Bayes algorithm, works very well. So what is that? It is the probability of this is independent of probability of this. That is what is the conditional independence. They are not dependent. So how can I write this? This is nothing but p of c given x is proportional to probability of x1 given c into probability of x2 given c, so on up to probability of xn given c into p of c. Okay. So if I write as a product, so for summation you use like this, for product you will use like this pi symbol, p of c given new, sorry. So I will write it here. Final, what is the equation we'll get? You can write it as probability of C given X. Okay, so set it as new for clarity is equal to product of, so this is summation, this is product, symbol we use in mathematics. Probability of xi, that is each feature, xi represents this each feature given that class, that is nothing but your likelihood, product of all the features likelihood into class. This is how the final result. Based on this only we'll classify. For this example, we'll see how we will classify applying this rule. This is called naive-Bayes rule. So only thing, simple thing here is it is the product of likelihood into prior probability. That will give my posterior probability. This posterior probability will decide the class. Okay, hope you got it. Now we'll apply to our example. So we got, just rewrite those values, what you got. Probability of spam is equal to, we got it as 3 by 5. Probability of not spam is equal to 2 by 5. So what is this probability is called as? This is called from step 1. These were called as prior probabilities, that is P of C. For each class, I am finding the probability. Next, step 2. I found out the likelihood, that is probability of X given C. So we found out probability of X1 is equal to S given spam, class is spam. This is equal to 3 by 3, 1. Probability of X1 equal to S and then not spam. This we got it as 0. Probability of X2 equal to S and then it is a spam. This we got it as 2 by 3. Then we calculated probability of X2 is equal to S given not spam. This is equal to 1 by 2. Now, step 3, we have to calculate the posterior probability. So for class spam, so for class equal to spam, what is the posterior probability? That is naive-Bayes rule. So probability of spam given this x new. What is x new? X1 is equal to S, comma x2 is equal to S. The probability that you have calculated is for this only. That is the reason I asked you to see the question carefully. What is that they are saying? What is that you are trying to classify? Using what features? So this is, according to naive-Bayes, is proportional to probability of, and here. So there are two probabilities. I will take the conditional independence. That is P of x1 given C into P of C. So this is probability of x1 is equal to S given it is spam. Why spam? Because I am finding this for class spam into conditional independence. X2 is equal to S given that is spam and then into probability of being spam. C means spam. Okay. So this is nothing but equal to, already calculated these values. X1 equal to S and given it is spam. X1 equal to S given it is spam is 1. 1 into probability of X2 equal to S given it is spam. This one 2 by 3 into probability of spam. Probability of spam is 3 by 5. So this comes out to be 0.4. Now similarly you find for posterior probability. What you are finding is the posterior probability for class not spam. So my C is equal to not spam now. This is nothing but P of not spam given x1 equal to S and x2 equal to no, sorry, yes. This is nothing but equal to probability of x1 equal to S given not spam. The class has changed here. Into probability of x2 equal to S and then not spam into probability of not spam. So this we can calculate from here. We already got those values. Probability of x equal to yes not given not spam. So it is 0. 0 into you will get 1 by 2 into probability of not spam is 2.4. This is 0. Now how will you classify? You will classify, you will check which class has the highest probability. That is probability of class spam is greater than probability of the class not spam. Okay, this is 0.4, this is 0. Therefore, what is the end result? We classify the given email x new, right, as spam. This is how the naive Bayes classifier works. Okay. Just to summarize, there are only 3 steps. First step, you calculate the prior probability of each class from the given data. Second step, calculate the likelihood as the conditional probability. So for the given class, to find out what that feature value says, the probability. How many say yes or how many say no based on the question given. Then you take the product of prior probability and likelihood. That will give you the posterior probability. So you compare the posterior probability of the different classes. Whichever class has the highest probability, so we classify the given input in that class. Hope you understood this very simple concept. In the next video, we'll see some more advanced concepts using naive Bayes classifier. Thank you for watching. Please like, subscribe, and share.